The next two sections, 2.3 and 2.4, we're going to be looking at two different measurements. One is the measure of center, one is the measure of spread. So both of these are going to be values that you can calculate from a data set to describe it a little bit. Measure of centers, kind of looking at the tendency. Okay, does it tend to be high, does it tend to be low? And now instead of just looking at a dot plot or a histogram and estimating which one's higher or lower, we're going to do some calculations to find a value that can measure that. Now I'm sure if you're watching this, you've seen some of these values before, especially for the measures of center. Okay? We have mean, median, and mode. And I have mean and median a little bigger here because they're the ones we're going to concentrate on. Okay? Mean is going to be the average. Okay? You add up all the values and divide by how many values are in the data set. Okay? So this is looking at all the values and how big or small they are. The mean takes into account the weight of those values. The median is the middle value. Okay, you line up all your values from low to high, and you're just counting position. And we're looking at the middle position. Doesn't really matter how big or small the values are to the left or right, how much they're increasing by. We are looking at position in this case. Okay? And the mode, this is the number that appears the most. Okay? A lot of times that mode will be around where the median are. Okay, but not always. Sometimes there's just a lot of high values, but the majority of values can be a lot lower. So we're going to have to see the mode where it falls. Now, we're going to look at the relationship between mean and median a little bit. Okay, we should know how to calculate both of these at this point. You also have a calculator that will do that for you. Okay, so let's utilize that TI-83 calculator, TI-84. Enter a list into your calculator, and we're going to be looking at one variable stat. Okay, the one variable stat will show you both the mean and median. The mean is going to be the X bar, and the median, if you scroll down, will be in the 5-number summary where it has MED as its label. Okay? Now, deal or no deal. This was a game, I believe it's still on, where you had to select suitcases. There was a group of suitcases out there, and you selected one. Whatever was inside, that was going to be the amount of money that you win. And there were times when you could see another suitcase and decide, do I want to keep my suitcase or replace it? All the suitcases that were up there had a different value in it. And here's the values that it could have been. It goes from 1 cent all the way up to $1 million. Okay? Now, when they would advertise this, they would talk about the average amount that you could actually win. And the average amount here, let's take a look at it. We have it as $131,477.54. So if you're saying, okay, you play this game, you have a chance to win an average amount of $131,000, that's pretty good. Okay? If you look at the median in this case, the median is $875. So there's a little bit of difference there. If you're trying to advertise what's happening or how much you have a chance to win, you're going to want to look at the bigger number. That $875, not quite as nice and appetizing as that $131,000 that you could end up winning. Now, both of these are measures of center, and they're giving very, very different pictures of what's happening in our data set. So what I want you to look at here are these numbers and what's happening with the numbers as we're increasing. So these are in order here. And we have 99-cent different here. We have $4, $5, and it keeps increasing a little bit. $15, $25, $25. Then it goes to $100 a couple times, $300. Here's $100 different, another $100 different. Now we're at $250. Now we're at $250 again, and now it goes up to $4,000. 5,000, 15,000 difference. The difference in between values is getting bigger and bigger. Excuse me. 25,000, 100,000, 100,000, 100,000, $250,000 difference here. So if I was making a plot of this, if you just looked at the points of where they fall on a number line, the beginning points are going to be very close together. And as you get farther and farther away, those gaps are getting bigger and bigger. Okay, and eventually they're getting very, very different apart. So if there's an equal number of values up here from where the median is. The median's the middle number. We have a bunch of points that are close together on the right-hand side and very spread out on the left-hand side, the higher side. So you really got to think, how is that affecting our mean and our median? And that's what we're going to look at now. Okay? We're going to start looking at where the numbers fall. Is the mean and median going to be affected by those numbers? So which one's going to give us a more true center, measure of center, depending on what's going on with our data set? So here's 3 data sets that we looked at before we looked at their dot plots. We looked at the monopoly prices for the properties, the snowfall in inches for cities, and then quiz scores. And here's a dot plot that went with those. Okay? Now if we look at the monopoly one, this is the most symmetric shape that we have. And if you look at where the 208.6 and the 210 is, I'm not going to know exactly where they are, but the mean is right about here. The median is not too far away. They're very close to each other, and that's a symmetric data set. For the snowfall, we have a high peak over here, and then it starts getting spread out. This is going to be skewed to the right. Now, if we looked at this snowfall, where the mean and median is, again, I'm not exactly sure where it would be, but let's say the median would be right about here. The mean is a little farther down. Okay, this is only 1.4 away. This one ends up being a little farther away, closer to 6 away from each other, a little bit above 6 away from each other. For the quizzes, the peak over there, you have an outlier all the way down here, a couple ones over here. This is going to be skewed to the left. And if we look where this mean and median is, okay, the mean, say, would be right about here. The median is going to be falling a little closer there. Okay, a little higher up to where the cluster of points are. Okay, the point of this is showing is, and this is also a good amount away, over 6 points or units away from each other. The point of this is that the shape of the distribution is not to tell you where the mean and median fall. Okay, when the distribution is symmetric, the mean and median are very close to each other. Okay, they're very close to each other, and sometimes will be falling on top of each other if it's on be a nice, beautiful, symmetric shape there. Okay, when it's skewed, the outliers that are causing the skewness, those random points that are out far away, that's going to pull the mean down. Okay, and that's making the mean, when it's skewed to the right, will be higher. So when we have skewed to the right, the median is less than the mean. When we have skewed to the left, this mean is getting pulled down, and our mean is less than the median. So just knowing the shape of the distribution, you should now be able to pick out, okay, which one's my mean and which one's my median. Okay, this is one, skewed to the right is what happened with the deal or no deal. We had those numbers when it got to the higher numbers that were 250,000 away from each other, 10,000 away from each other. Big gaps, so those numbers were very spread out. The lower numbers, they were real close to each other, a couple dollars away from each other. This is why the mean is getting yanked down in that direction. Okay, so let's do a little more investigating here. Okay, again, that's a good fact to know that I just had up there. The skewness is going to show you where the mean and median fall with each other, in relationship with each other. Okay. Now here we have the weight of the rowers of the 2004 U.S. men's Olympic team. So again, another data set that we looked at where we had basically a good cluster of people. We had one outlier. Okay, that was the coxswain. He's the guy who keeps the pace, the rowing, so he's the one who tells people when to row. You don't want that person to be a big guy if he's not helping row. You want to find a very light person to be there. Okay, so let's look at these mean and medians. Okay, if we found the mean and median of just the whole team, everyone who's on the roster, their mean and median, 118.926 compared to 195 for the median. Okay, so again, it's kind of hard to say are they close to each other or not without actually seeing a dot plot of where all these values fall, how far away they are from each other. But let's just say this is our starting point. If you look at the whole roster, There it is. Let's take out the coxswain. He's an outlier. He's smaller than everyone else. He's going to be away from our pattern here. Okay? And let's take a second and think. Which number do you think is going to change, if any number? Remember, the mean is adding up all the numbers, taking all the values and adding them up, getting a sum, and then dividing by how many numbers there are. The median is all about position. Okay? Taking one away, taking out the outlier, does that move that position, and where does it move it to, and how will it move it? So here's what happens to our numbers. Okay? If we take out a low outlier, our mean goes up to 191.577. Our median stays the same. Okay? So our median didn't move that much. That outlier didn't really affect where the position was. Maybe switched it a little bit because now we have a different number of total points. But that median didn't move all that much. The mean, that outlier was pulling it lower. Now it got pushed up a little bit. Now that outlier is not lowering our value anymore. Okay? So let's put him back in. And if I change the max value, let's say there was a typo, okay, with a max weight of 329. So we took that max person on there and we changed it to 329. Let's say his weight got plugged in there incorrectly. So now instead of having just one low outlier, we also have a very extreme high outlier, 329 pound person. So he's very far out there. He's very far up compared to everyone else. Okay? Our mean is increasing more. It's going up from 192 now, so it's increasing more. Our median, again, is not changing. Putting the coxswain back in there, we're back at that one position at 195. And if we just take the highest person and make him even higher, is that middle position moving? Okay, that middle position is still the same spot. Okay, so that 195 is going to stay that same place. Now, what if we take that 329 and let's make it 2,229? So now it's a super extreme outlier. It's very far out there. And you can see the median, 195, 195, 195, 195. The mean goes up to 263. Okay, so that outlier is really pulling the mean up. Okay, so what I'm hoping you see here is that the mean is affected by outliers. The median is not. Okay, the median might adjust it a little bit because the position might move just that little slightly, but it's not going too far. Okay, yes, it will depend on the data set, but in this case, it stayed 195, even with extreme outliers of 329, 2,229. The median is changing every single time. Sometimes not a great amount, but sometimes a very good amount, like that 263 all the way up there. Okay? This means that the median, resistant, a measure whose value is relatively unaffected. When it says relatively unaffected, that's because, again, it might move a little bit. It might move one position to the right, one position to the left, if you have an outlier taken away or an outlier is added to it, but it's not going to adjust it too much. The mean is being adjusted a good amount. So a value is relatively unaffected by the presence of outliers in a distribution. Okay? So the key takeaway here is that the mean will be affected by outliers. Okay? So if you have a data set that has an outlier, know that that mean might be getting pulled one way or the other, so it might not be the best representation of where the center actually is. The median is not affected by outliers. So if you have a data set with outliers, the median would be the better point to use, the better level of measurement to use to describe where the center is. Okay? So that's the key thing from this section. Outliers affect the mean. The median is not as affected as by the outliers. Okay? So here's one other problem we talked about. Primary and secondary seatbelt laws. The states within primary seatbelt wearing laws has a mean compliance of 86.4%. The states with secondary laws have a compliance rate of 77.14%. So primary seatbelt laws, you have more people wearing their seatbelts at 86.4%. Secondary laws, it drops down to 77.14%. So there's a difference there. Okay, we're not trying to calculate, say if it's significant or not, but there is a difference. We can see they're not exactly the same. Can you draw a causal conclusion about the state seatbelt laws since the difference in compliance mean is so large? Okay, this is just looking at center. Now that we're actually calculating numbers, we're not just estimating, saying, okay, this one's higher, this one's lower. Okay, we actually have values that go with it now. And the question is, now can we say that there's a difference, and can we say that it is cause and effect difference? Okay, and the answer is no. The reason is because this was an observational study. With an observational study, we did not control any outside factors. We didn't have any random assignment. So we cannot say that the seatbelt law, the type of seatbelt law, is affecting the compliance rate. Okay? It doesn't really matter how big of a difference it is. The important thing when you have cause and effect, is it an experiment that has random assignment, or is it an observation? Observations, you cannot have cause and effect. Experiment, as long as you're controlling outside factors, you can have cause and effect. Okay? So that was 2.3, measures of center.